We'll show you each part of the system, starting with the wheel clamps that easily mount on the inside or the outside of rims from 10 to 19.5 inches in diameter. Aluminum feet minimize any damage to expensive rims. There are run-out adjustment knobs and a precision mounting disc on which all of the gauges mount. The wheel clamps are first mounted on the wheels without gauges attached in case the clamp is accidentally dropped. All of the gauges are stored on the calibration bar, which is built like a perfectly square vehicle. This allows the technician to verify calibration in seconds before each alignment. The laser guns are powered by flashlight batteries and have no cables to trip over or battery packs to recharge. They shut off automatically, and you can get hundreds of alignments from a set of ordinary D-cells. The lasers are projected across the front wheels and to the rear gauges. Factory toe is set with precision dials that read in inches, degrees, and millimeters. The rear gauges have precision reflecting mirrors and centering scales. Rear camber can also be read with this scale simultaneously with toe. In addition to the 4 toe gauges, caster, camber, and SAI are measured in the front with this gauge. All of the gauges have shock-resistant outer cases to minimize damage in the event that they are dropped. Now that we've shown you the equipment, we will show you how to do an alignment, first on our Easy Train vehicle simulator and then on a car. Easy Train simulates a 4-wheel vehicle with wheel clamps mounted and compensated for runout. You can see the wheel clamp mounting discs in the front and in the rear. The front steering axis can simulate caster and SAI swings of 20 degrees in and out. There are also toe adjusting tie rods for the front wheels. The steering wheel can be locked in the straight ahead position. In the rear, you can adjust toe on each wheel, and you can simulate a straight axle that is not aligned with the center of the vehicle. Assuming all the wheel clamps have been mounted and run-out adjusted, we will first measure front caster, camber, and SAI. With the brake pedal depressor in place, the technician mounts the gauge on the disc in the straight-ahead direction and reads camber. To read caster, he swings out 20 degrees, levels the gauge, and zeroes the caster scale. Then he swings in 20 degrees, levels the gauge, and reads caster. To read SAI, he swings out 20 degrees, rolls the gauge to zero the SAI scale, and locks the gauge in place. Then he swings in 20 degrees and reads SAI. The procedure is repeated on the other side, and the readings are compared to each other and factory specifications. Adjustments are made if necessary. Since caster and camber adjustments disturb toe, these are made first. First, the technician would select the type of alignment he would make, and the selection is based on the type of vehicle, what the customer wants, and the condition of the vehicle. He would choose between a front centerline alignment where the wheels are aligned in the front to the vehicle centerline, a front thrust line alignment where the wheels are aligned in the front to the rear wheels, or a total 4-wheel alignment where all of the wheels are aligned to the vehicle centerline. First, we'll show you how to do a front centerline alignment. The 4-wheel clamps are mounted and run-out is adjusted on the 2 front wheels. You're looking at the simulator from the front, and the rear gauges are mounted. The front gauges are mounted. The technician locks the steering wheel. Sets factory toe, turns on the laser and points to the rear. On the driver's side, he sets factory toe, turns on the laser, points to the rear, and points the cross laser to the reflector on the opposite side. He'll now adjust the cross laser so that it reflects back in the hole, as you can see. After adjusting the cross toe, he reads the numbers on the rear centering scales. On the passenger side, you can see that the laser hits at number 8. On the driver's side, it hits at number 4. Using both front tie rods, the lasers are adjusted halfway between, or to number 6, which is halfway between number 4 and number 8. The passenger side. The driver's side. The technician would check that the cross laser is still on the 0, and then he tightens the tie rods, and that completes a centerline alignment. Next, we'll look at a total 4-wheel alignment. For this, all 4 wheels would have run-out adjusted. You've already seen the first part, where the front wheels are adjusted to the vehicle centerline. A 4-wheel alignment is completed with a rear adjustment. Looking at the simulator from the rear, the technician is adjusting the laser to reflect back to the center on the thrust line scales. And that completes a 4-wheel alignment. Last, we'll show you a front thrust line alignment where the front wheels are adjusted to the rear wheels. All 4 wheels would have run-out adjusted, and the rear gauges would be set as 0 toe. The front gauges would be set to factory toe, and the cross laser would be adjusted to 0 if necessary. Next, the technician would read the numbers on the thrust line scales. We're now looking at the simulator from the rear, and you can see the lasers reflected back to the thrust line scales. On the driver's side, the number is 6, and on the passenger side, the number is 2. Using the front tie rods, the technician would adjust both lasers halfway between. Halfway between 6 and 2 is 4. He adjusts the driver's side to 4. And then the passenger side to 4. He verifies the cross laser is still centered, locks the tie rods, and that completes a front thrust line alignment.